Welcome back to question 2 of this series, where we use the first order integrated law to find the concentration of a reactant at a given time. We ended off with this question, which reads, cyclopropane rearranges to form propene in the gas phase according to the reactions shown here. The reaction is first order in cyclopropane and has a measured rate constant of 3.36 times 10 to the power of negative 5 at 720 Kelvin. If the initial cyclopropane concentration is 0.0445 molars, what is the cyclopropane concentration after 235 minutes? To do this problem, we'll need the first order integrated rate law, and that's highlighted right here from question number 1. I'll keep it on the screen so we can refer back to it. We've been told that K is equal to our constant 3.36 times 10 to the power of negative 5, and since it's first order, we have s raised to the power of negative 1, so the units are 1 over s. The initial concentration, let's call that A sub 0, is 0.0445, and we are looking for the final concentration, which I'll refer to as A sub t is equal to, I'll put a question mark. The time is given in minutes, whereas in question number 1 it was given in seconds. So we have to add an extra step and convert this into minutes. 235.0 minutes. How many seconds are in a minute? We have 60 seconds per 1 minute. So we multiply this number by 60. Using our calculator, 235 times 60 is 14,100. 14,100 represents T. Now here's that formula again. I'm going to substitute all of the information that we just found out. We're looking for A sub t, so I'll keep that blank. Ln of A sub t is equal to negative this number, negative 3.36 times 10 to the power of negative 5. And I'll write the units in, 1 over s. That's being multiplied to the time, which we found out to be 14,100. And that has the units of seconds. This is why we converted into seconds, so that this and this will cancel out. Plus ln of our concentration initially at 0.0445. Let's go ahead and find out what the right side of this equation is. Negative 3.36 times 10 to the power of negative 5. Multiply to 14,100 plus ln of this number, 0.0445. We end up with the following number on the right side. Let me write that down. So we have ln of our final concentration is equal to the number that we just found, negative 3.5860. To isolate for A, we'll need to raise both of these numbers to the base e, because what this e will do is cancel out the ln. A is equal to the expression on the right side. So shift, you can press this button if you like, answer. This gives us a final concentration of 0.0277, and we need this to 3 significant figures, because most of our numbers were 3 significant figures, minus this one, but eventually it led to 3. 0.0277, and in scientific notation, that's 2.7 times 10 to the power of negative 2 molars. That's the answer to question number 2, and that is how to find the concentration of a reactant at a given time using the first order integrated rate law.